y equals x plus 1 brackets times bracket x minus 2 to the power 2 times bracket x plus 3. The highest power of x when you expand this bracket in your mind's eye is x to the power 4, and it's a plus x to the 4, isn't it? So here, as x tends to infinity, y tends to infinity to the power 4, which is infinity, and as x tends to minus infinity to the power 4 tends to infinity, doesn't it? Because minus times itself 4 times gives a plus. So it's going to shoot up here very quickly, and shoot up here very quickly. The roots are x is minus 1, x is 2, and x is minus 3. So it crosses the axes at minus 1 and minus 3. So there's minus 3, there's minus 1, and here's 2. Okay, so that's good. So now what happens here? Well, this is squared. So because this is squared, you can think of your product. If you moved that over here and you differentiated this, it would be your u, and the other two terms here and here would be combined to be the v. You'd have u dv dx plus v times du dx, and the reason I'm saying that is because when you differentiate that, you get a 2 bracket x minus 2, because it's something squared. So I hope you could see that you'll still have an x minus 2 common to the u dv part and the v du part, and that means it's the root of y dashed. So it means that when x is 2, the gradient is 0. So this is a turning point here. So it's a minimum or a maximum. Because this shoots up to infinity, it's going to be a minimum. So when x is 2, we've got a minimum here. And I know that was a bit confusing, but I think I'm not going to say it again actually. I just said it once. So it comes down here to a minimum. When x is 0, let's have a look at that then. Put in 0. You get 1, you get 3. 3 times 1 is 3. Times 4, which you get here, is 12. So it shoots up to 12, say. Here, so it's going to come down, minimum, through 12, turn somewhere, might turn up here and then start to come back down, yeah? So I would imagine that would happen. And then come back down to a minimum and then turn back up here. Agreed? So let's try that then. That's our first guess. So let's just do that then. Oop, that's a terribly drawn curve with the digital pen. So I'm going to try once again to see if I can do it. That's a bit better. So there's our curve. Now let's just confirm that then. So when x is bigger than minus 1, x is bigger than minus 1, this would be positive, wouldn't it? After minus 1. This is going to be positive anyway, and this is positive. So that's why the curve after minus 1 is always positive. Because you've got a positive here, a positive here, and this is always positive. So I hope you can see that. When x is less than minus 1, and bigger than 3, in this region here, can you see that this would be, that plus 3 would be positive, but this one would be negative. So a negative times a positive is a negative. That's why it goes underneath here. It comes back up to 0. And when x is less than minus 3, this is then negative, and this is negative. So the two together make a positive. This is always positive. So that's why we swing back up positive. So that looks like it. I'm fairly happy with that curve. So let's have a go at the sketch then. X plus 1 times x minus 2 squared, so I've got that there, so all I need to do is get rid of this. X plus 1 times x minus 2 squared times x plus 3. We want to plot it from, say, minus 4 to encompass the root. Up to 3 is fine. So let's have a look. Yeah, see the minimum at 2, which is just here. And then it comes back up, it does a little maximum here before it goes through 12, comes back down, does a minimum, between -1 and 3, and then shoots back up to infinity.